So the good news for this lab is it is very much like the last one. Like so much so that you might even be able to recycle some of the stuff from the previous lab, especially things like sources of error in that, well, you're whirling this rubber stopper around and around the circle using exactly the same piece of equipment you used the last time. So all the sources of error that were present in that lab are also present in this lab, so you can save yourself a little time. Okay? The things that are different are obviously the setup of the experiment. In our last one, we were trying to find out what was the effect of radius on speed. Now, we're not testing radius anymore. Now we're testing centripetal force. So in this lab, rather than changing radius, we're going to keep radius the same. And we're going to change the centripetal force. The way we change the centripetal force, and this might be helpful to you for your other lab report, okay, is that we change the mass that's hanging below. Because if I put more mass down below, I change what? What's pulling on the mass? Gravity. If there was no mass there, would there be any tension in the string? No. So by changing the mass, we change the force of gravity, which changes the centripetal force, and that's what we're trying to do. Okay? So we're changing the centripetal force, we're keeping the radius the same, and we're still looking for a change in two responding variables. One of them we're timing, the other one we're using that time to calculate. Okay? Same as the last lab. Right? Our responding variables are the same as the last lab. Those are the things we recorded. Well, we recorded one and calculated the other with it. Okay? All right. So you guys can do your variables there. Okay, I've given you some pretty big hints for those. All right, for our hypothesis, here's what we're looking for. Okay, if, and then statement, where the if part is going to talk about, okay, how, or the relationship between centripetal force and speed. Okay, so what is the relationship? Okay, between centripetal force and speed. The and part describes the experiment, same as always. Okay. The then part, I want a prediction for what will happen to speed as centripetal force is increased. Okay. And predict the results of increasing FC, sorry, I put the arrow over that. Okay. Increasing FC on speed. Okay, so for our procedure, like we said, pretty much the same as last time. Okay, we're going to start out with 50 grams, but when you do your calculations, that needs to be in kilograms. Keep that in mind. Okay, we're going to start out with 50 grams hanging on the end of the string. Okay, you're going to have that rubber stopper. Our radius for all trials will be 40 centimeters, 0.4 meters, incidentally. It needs to be in meters when you do your calculations. Okay, so we'll have a radius of 0.4 meters, and we'll do exactly the same thing we did last time. We will time 20 revolutions twice for each different centripetal force. Okay, and then we will calculate an average time by adding them together and dividing by 2. We will calculate the period by taking the average time and dividing by 20. Okay, we'll calculate speed using, and it actually says that in the analysis, calculate the speed using this formula. Okay, and then calculate the centripetal force. Okay, again, calculating the centripetal force, you're not calculating that using this formula. Okay, that's the formula we're trying to prove. We don't want to use that to calculate the centripetal force. What's providing the centripetal force? Gravity. Should be able to calculate the centripetal force for each trial, and possibly our first lab. In analysis question, whatever it was. You're welcome. Yeah. Okay. Everyone follow on the procedure. Okay. So for our analysis, okay, analysis pretty straightforward. The first three are just filling in the table. Okay. For number 4, it tells you exactly what I just told you. Here's how you calculate FC. Okay. Then you're going to plot two graphs. One graph of speed versus centripetal force. Again, remember to put your manipulated variable on the x and you're responding on the y. Okay. And use a polynomial fit. Sorry, you're only going to do one graph. Sorry, I changed that. So one graph. Okay, you're going to plot a graph of speed versus centripetal force and use a polynomial fit line. So when it says trend line, okay, and you click on that, you're going to want to use polynomial, not linear. Okay, everybody follow me there? Okay. And then in number 6, I want you to do, so the relationship between centripetal force and speed is not linear. Okay, and you'll see that when you apply the polynomial fit. Okay, describe the relationship without naming it. Okay, and explain why it's not linear. So in question number 6, basically I'm telling you, look at this formula, okay, but think about it manipulated for V, because we're trying to find the effect of this one on this one. So when that's manipulated for V, remember that it looks like this. Okay, so when you're explaining that, think about that formula. I just want an explanation. I'm not looking for you to name the relationship. Okay, I'm just asking you, talk to me about what happens. Okay, when I increase FC, what happens to V, and a bit mathematically. Okay, not when one goes up, the other goes up. That's obvious. How does it go? Okay, it's obviously not linear. Right? If I double the centripetal force, I don't double the velocity. Okay, spoiler alert, that doesn't happen. Okay? I want you to kind of explain what it does. All right, and then same as always, conclusion, copy-paste your hypothesis, explain why it's accepted or rejected. Okay, an evaluation, 2 sources of error. Like I said, you can probably recycle the sources of error from the first lab, since everything else is pretty much the same. Okay? Any questions on what we're doing? Okay. Also a reminder, it is the rubber stopper that is whirled around and around in a circle, not the metal masses. Okay? They need to hang below the circle.